All right, this is percent yield, section 14.4. And here's what we're going to try to do. One, explain what's meant by the terms actual yield and theoretical yield, and be able to calculate the theoretical yield, and then determine percent yield for a chemical reaction. All right, first of all, when we're talking about the theoretical yield, this is what we have done. Everything we have done up to this point has been to find the theoretical yield. So every time that we've done a calculation, we have been finding theoretical. In other words, if you were to do that experiment in the lab, it would come out a little bit different. Because there's always some factors that make a difference as to why not everything proceeds 100%. Okay, so there's the actual yield. What you get in the lab, that's the actual yield. The actual yield is always smaller. Okay, so the theoretical yield would be, hey, if everything were perfect, if life were perfect, we'd get this much. Actual yield is what it really is. And then the percent yield is comparing those two. So it's the actual over the theoretical to figure out what the percentage is. So percent yield is actual yield divided by theoretical yield by 100 times 100. And if you ever forget, you just always have to do it so that you get less than 100%. You can never get more than 100% on any of those. So you're always taking the smallest one divided by the largest one. All right, so let's work through a problem, and this is always a little bit confusing because it kind of looks like the problem's already done for you, and that's what usually confuses people. They can't figure out, well, what am I supposed to find because it's already there. Well, and that's actually what you have to do is find the same thing that they already gave you. They will have to tell you what the actual yield is of something. This is what was done in a lab. You cannot calculate that, and you can't do these problems unless they tell it to you. So they will give you this in every problem that you do. They'll always give you the actual yield. Okay? Your job is to take what you're starting with and figure out how much of that would be if you did it with the theoretical. So, in other words, we're starting with 4.95 grams of sulfuric acid, and we want to figure out how much calcium sulfate is going to be produced. We know that the actual was 5.12, but what we got to figure out is, well, what would happen if this were perfect? How much would we get? And that should be a little bit bigger than that number. All right, so let's work through that problem. All right, so here's the problem, and I've kind of set it up, and this is what gets confusing is people look and say, well, I've already got this, what do I got here? But you still got to figure that out. All right, so that's really what you're trying to figure out. So you want to figure out how many grams of calcium sulfate given 4.95 grams of sulfuric acid, H2SO4, and you're going to do all the same steps that we would normally do. We do our change it to moles, mole ratios, change it back to grams. Same thing. Okay, so 1 mole H2SO4, 98 grams. That's all of those added up together. Now we're going to do mole ratios between sulfuric acid and CaSO4. It looks like it's 1 to 1. So 1 mole CaSO4, 1 mole H2SO4. Run out of space here. And our last thing is we need to convert back to grams of CaSO4. And let's see, molar mass is 136.2 over 1 mole. Can't quite make it all on there. So we would take 4.95 divided by 98 times 1 divided by 1, no problem, times 136.2, and I get 6.88 grams. Okay, so this number, this is my theoretical. So this is always the bigger value, and so you can see I got 5.12, so if I put in 6.88, take 5.12 divided by 6.88 times 100, this will give me my percent yield. So if I do that, I get 74.4%. So the problem, doing what we're doing here, that's exactly what we've been doing the whole chapter. Trying to figure that out. Theoretical yield is what we've always done. Actual yield, they have to tell you that in the lab. You have to figure that. They have to give that to you, and then you just divide those two and give your percent. And that's really the only new thing in this particular section. All right, we are done with stoichiometry here. So, good thing, probably.